All right, welcome back. Now in this tutorial, we're going to consider another technique that we use when it comes to text vectorization. Okay, so previously we've considered bag of words, then we also saw TF-IDF. Okay, then we got a theoretical understanding of both of these concepts. Okay, and some demonstration of bag of words, which later on I'll show you how we do TF-IDF, right, when we go to the lab session. All right, now another technique that we use when it comes to text vectorization is what is referred to as word embedding. Okay, and word embedding, we have two techniques that we use, which is word to vec and glove. All right, word to vec and glove. All right, so we're going to consider this word embedding and the respective techniques as well. All right, okay, because I mean, it's important to understand that in natural language processing, the most important thing to do is to be able to represent your text in the form of vectors, okay, to vectorize your text so that you'll be able to build any natural language model over there. Okay, you'll be able to feed it to a natural language model, algorithm to build a model. Okay, so that's basically what we are understanding right now. Before you even start doing anything, you need to know how to pre-process your text, right, and then vectorize it in order to further build NLP models. Okay, so let's start with the word embeddings. As I said, we have two main techniques under word embedding, which is word to vec and then glove. All right, now first going to understand what word embedding is before we get to each of these two different techniques. All right, so let's start with word embedding. Okay, so in word embedding, all we're trying to do over here is to find a better way of representing the text in the form of vectors. Okay, so we have seen some other techniques like bag of words and then TF-IDF, right? But there are still some problems with them. Okay, what word embedding is trying to solve here is that how do you represent the words, right, in a vector form such that two vectors close to each other represent two similar words? Okay, two vectors that are close to each other represent two similar words. Okay, if you have if you're talking about image or in computer vision, you don't need to worry about that, because in computer vision you have numbers ranging from 0 all the way to 255. Okay, and you don't need to worry. Where if it's 0 is black, if it is 255 is white. Okay, so you don't need to worry about it. So if you have an image, all you need to do is to just indicate where those numbers are on the image, and then you'll be able to extract those numbers. And that is, all that you need to do when it comes to image representations, right? But if you come to natural language processing, it's not like that. Okay, natural language processing is not like that. So if you have a word like admit and you use one hot encoding, like we saw earlier on, okay, you're going to see something like this. Okay, so you're going to represent, you have a lot of text. Okay, you're going to have a lot of text, and then with this a lot of text, you're only going to represent one when you come across admit. Okay, when you come across admit is when you're going to represent one, but apart from that, anything else is just going to be 0. Okay, all the other letters or text are going to be represented as 0. Okay, only when you come across admit, because that's the word you're looking for. Only when you come across admit is when you're going to mark it as 1. Okay, for instance, if you see another word, say accept, okay, it's only when you encounter accept is when you're going to mark it as 1. All the other numbers or all the other text are going to be represented as 0. Okay, now this is the problem. If you do it this way, right, now if you have a sentence where you have admit and you want to predict the next word, for instance, maybe you did something wrong and you need to admit that you have done something wrong. Okay, you need to admit your fault. Okay, so if you say admit, okay, then the other word that you can use is accept, right? Accept your fault. Or maybe you have applied to some schools and they have given you admission. Okay, now they have admitted you. Okay, so what you have to do is to accept the offer. Okay, so the words this admit and accept quite they are quite close, right? Because they actually fit in a sentence and make a meaning. Okay, they are quite close. However, if you do something like this, you see where accept is. Okay, so if accept is here, okay, and then admit is here, you see that there are quite a lot of things that will come in between. So if I have a sentence, then maybe the sentence is like this. Let's say this is how the sentence is. You have been admitted, right? You have been admitted to the program. Let's say this is how the sentence is, right? Comma, please dash offer. Okay, now what do you think will be the word over here? Let's say this is what you have, and you want your natural language processing or your NLP model to predict the word that is going to be here. Okay, now in human intuition, I can predict that this is supposed to be accept. Okay, the word that is supposed to come here is supposed to be accept. Okay, supposed to be accept. Now, for your NLP model to predict, it has to establish a relationship between accept and admit. Okay, it has to find some kind of closeness, right, between accept and then admit, right? But if it doesn't find it that way, because if you're using that one hot encoding, right, this one will have its own sparse matrix, this one will have its own sparse matrix. So there's no kind of relationship between the word admit and then the word accept. Okay, so that becomes a problem over there, right? That becomes a huge problem over there, because if this is the matrix for accept, right, this is the matrix for accept, this is the matrix for admit. Okay, this is the matrix for admit. Now, there's no relationship between these two, right? There's no relationship between these two matrices. It becomes difficult to establish that kind of a relationship. All right, because they are actually very sparse, right? They are very sparse. When I'm talking about sparse, I'm talking about here having so many zeros with just one, right? With few ones, right? So many zeros, right? So many zeros with few ones, and it's even going to make this one have very, very high dimension. Imagine we have 1,000 words, right? Or maybe 10,000 words. Okay, which means that we're going to have 9,999 zeros with only one over there. Okay, which that 9,999 zeros, they don't really make any sense, right? The only sense that is making is just that single one that is in there, and it's going to be like that. So if you have 10,000 words, all the 10,000 words are going to have this kind of sparse matrices. Okay, which is going to be difficult for your NLP model to even do anything sensible. All right. Now, let's say that we have two words like this, because in the dictionary, right, we have lexicographical, right? The words are, arranged in a lexicographical way, right? That is alphabetical way or something like that, right? So we have something like maybe A will come after that, able will come, about will come, something like that. Okay. Then you see accept is somewhere there, admit is somewhere there, right? So if we have word like say A and then able, right? Now, these words are quite close, right? If you see A is just here, able is here, okay? So if, for instance, we're able to establish A, we're able to bring this A here, right? And establish it as one, right? Now, if you have a sentence, then I said, okay, let's say we have a sentence like maybe dash man is able to walk. Okay, let's say this is the sentence that I have, right? Now, I have able here, okay? Now, your NLP model, right? Your NLP model, you want it to base on this, okay? Based on this able, and predict the word that will come here. Now, if you have several other words, like maybe a machine, right? Something like that, okay? Right? Is, right? Something else. Okay, you have these words that your NLP need to look and then predict the word that is here. It's possible that it's likely to predict that this is A, right? Because in the matrix, A is very, very close to able. So once it finds able here, it is going to predict that the word that is supposed to come here is supposed to be A, right? And it is going to make a sense, because a man is able to walk. That makes sense, right? Than saying that machine, that may be predicting here, machine man is able to walk. It doesn't make sense. Or maybe right, our man is able to walk. That doesn't really make sense. Is man is able to work. That doesn't really make sense. But it will be able to predict error, because they are quite close to each other. Okay, and that's what word embedding is trying to do. Okay, that's what word embedding is trying to do. Okay, let's take this sentence, right? So the sentence here is, I like playing with my pet cat. Okay, so your pet name is cat, and you like playing with the pet cat. Okay, now let's say that we don't have this, we don't have this cat over there. Okay, we don't have this cat over there, and this is what we have. Now, if we feed this one and then we said, okay, go through all the features that I have and then predict, right? Now, let's say that your model went through all of that and then predicted car. Okay. Now, car is not really related. Okay. Car is not really related to, cat. But you can see that if you go through, you see where cat is, right? And where car is, right? There's some kind of closeness over there, right? But ideally, we want to predict cat, not car, right? You can say that, okay, car and then cat, they are very, very close, but it doesn't really make real sense, right? If we put car here, right? And then you say that I like playing with my pet car. I mean, very rare that you find someone whose pet is a car, right? The right word that is supposed to be here is supposed to be cat, okay? So the closeness of these things are very important. And if you use those one-hot encoding, right, those one-hot encoding, you're going to have a very sparse matrix. As I said, sparseness here means that you have a lot of zeros, right, a lot of zeros, right, 0, 0, 0, 0, and then only some few ones over there, right, the rest will be 0, 0 like that. Okay, all right. So what we're trying to do here is to make sure that we have the vectors, and the vectors are closer to each other. That is, words that mean or have similar context, they are close to each other. Okay, so for instance, if you pick, say, cat and dog, right? Cat and dog, they have similar context, so they should be closer to each other, right? If you have something like, say, king and queen, right? King and queen, they are quite similar to each other, so they should be grouped to each other. Have close to each other. Okay, similar vectors. All right, if you have something like maybe boy, right, boy and then girl, right, boy and girl, they have similar context, so they should be closer to each other, right? Man, and then woman. Okay, man and woman, they have similar context, so they should be closer to each other. They should have similar vectors. Not that man is having a vector which is somewhere here, woman is having a vector which is somewhere here, which is going to be very far from each other, and it's going to be very difficult for your NLP model to predict the next word given one word. Okay, this is very important, because if you realize when you're typing on your phone, okay, when you're typing on your phone and then your phone want to give you some auto suggest, okay, if you're typing on your phone want to give you some auto suggest. So if you type something like maybe WO, right, WO, it's possible that your phone will suggest woman. Okay, your phone will suggest woman, right? Something like that. Or maybe wood, okay? It will suggest something like WOMAN, right? Or maybe WOOD. It will be suggesting things like that. Or maybe WORD, okay? These are closer to each other, okay? WOWW. So it is going to suggest you words like that, okay? So instead of maybe you type WO, right? And it's suggesting something like maybe plastic, okay, suggesting a word like plastic, which is quite unrelated, okay, so you need something, a matrix which is having some kind of closeness to each other, right, in terms of their context. All right, and that's what word embedding is helping us to do.